Welcome to the Module 5, first lesson, Introduction to the Cloud. In this lesson, we will introduce some cloud concepts and how to manage data that is stored in the cloud. In the simplest terms, cloud computer means storing and accessing data and programs over the internet instead of your computer's hard drive. The cloud is just a metaphor for the internet. It goes back to the days of flowcharts and presentations that would represent the internet as nothing but a cloud, accepting connections and exchanging information as it floats. A web service is just a web page meant for a computer to request and process. A web service is a service offered by an electronic device to another electronic device, communicating with each other via the World Wide Web. In a web service, web technologies such as HTTP originally designed for human-to-machine communication, is used for machine-to-machine communication, which is called M2M, machine-to-machine. More specifically, for transferring machine-readable file formats such as XML or JSON. We can identify two major classes of web services. On one side, we have REST-compliant web services, in which the primary purpose of the service is to manipulate XML representations of web resources using a uniform set of stateless operations. And arbitrary web services, in which the service may expose an arbitrary set of operations. We will focus on the former. REST means representational state transfer. REST or Restful web services are one way of providing interoperability between computer systems on the internet. REST-compliant web services allow requesting systems to access and manipulate textual representations of web resources using a uniform and predefined set of stateless operations. The World Wide Web is used by billions of people. And HTTP is one of the most used protocols in the world. It is multi-platform and multi-operating system. So why not using it to transfer or share data between applications? That lead us to REST. REST is a standard way to exchange information between machines. What this exchange is called a resource. A resource is a URL or URI, Uniform Resource Locator or Uniform Resource Identifier. URIs are the equivalent of a noun. And verbs describe actions that are applicable to nouns, in our case to URLs. In REST, we use universal verbs only, that are get to retrieve information, post to add new information, showing its relation to all information, put to update information, and delete to discard information. An API that adheres to the principles of REST does not require the client to know anything about the structure of the API. Rather, the server needs to provide whatever information the client needs to interact with the service. we send a request of a resource and we get a response with a file format, JSON or XML, with all the information that we required. A URI or URL can be a book in the Amazon website. For example, this book, Restful Web Services Cookbook. This book has a unique URL that points to it. The price can change, new comments can be added, but the link, the URL, it is always the same. It points always to the book. But a URL can also be a sensor value. For example, this address here points to the last value of the temperature sensor specified by its URL. In this case, its value is 9.5 degrees. It's temperature of value 9.5 degrees. When we perform this address request, we receive, in this case, a JSON file with information as shown in this image. We have several fields as magnitude, value, time, date, etc. We could upload the information using the same pattern or receive information about a specific value. So why is REST so important? In first place, it is a client-server structure. The server has the resources and the client wants them. But what does it get? A representation of the resource, not the resource itself. A web page is a resource. A web page is a representation of a resource. Resources are just concepts. URIs tell a client that there is a concept somewhere. Clients can then request a specific representation of the concept from the representations the server makes available. The representation is the current state of the resource. We can have a resource here. Okay. Now we get different representations every time we request. The representation is the current state of the resource. For example, the current temperature value. Here could be 20 degrees, 21 degrees, and 22 degrees. Thus, every request from the client must contain all necessary information. It cannot take advantage of any context information stored in the server. That means stateless. Finally, all RESTful services must use a uniform interface, an interface that every client application is able to understand. We get this, as we said, using HTTP, using get, post, put, delete. There are many libraries that we can use to operate with REST services. For example, curl, pycurl, urllib, etc. Also, we can use a web page called URL to send and receive REST requests and responses. In the next lesson, we will make an example with urllib and Python. By using a REST interface, we want to operate with data. What we can do is retrieve information from the server using the get command. We can upload information to the server from my device using the post command. We can update information in the server using the put or patch methods. And finally, we can delete information in the server using the delete method. How does a REST command look like? It has three main parts. The first part is the URL or destination, the web address we want to send information to or from. The second part are the headers, main information about the command or method. For example, content type, if it's JSON or if it's XML. And normally also the key to access the data, normally called API key. So not everybody can access the data, only those who know the APK. Finally, the third part is where we can specify parameters in the body of the message. For example, in a get command, we can specify how to get the data. For example, if we want to sort the data or in which order we want the data, how many samples do we want to get, etc. We can use the web, I told you before, hurl.it, to get familiar with REST commands. For example, to get a list of the devices that we have, we can do the following. Choose the destination URL here. This is a web URL that we have to know, okay, for example, from carriers that we will be using in the course. Then we choose the method, get, post, put, etc. It is optional to use authentication. And then we write the headers. In this case, content type, we want JSON, the APK. This is number that you have to know before, for example, the user agent, if it's a Raspberry or whatever. We can include some parameters, in this case order. One is order of previous, and we can write -1 to get new words first. And this is what we get. We get 3 devices, total documents 3. Since we ask for a device, we get 3. Each of these is a device. So this belongs to device number 1. This to device number 2. And this to device number 3. Okay. These devices are named, for example, we get the name P1, we get Mac1, and we get DDD. The type of sensor, for example, temperature, some other information when they were created, the owner, and so on. Then we can ask also for this specific device here. Okay. We get the ID of this device. So if we include this in the URL, we get specific information about this device. And this is one of the good things of REST, that we can navigate, okay, through the hierarchy of our system in order to get information deeper and deeper. Information that we don't have to know in advance. We can get directly from the system. In the next lesson, we are going to see how to work with carriers. The post method works in a similar way. We get destination, we get headers, again JSON and APK, and we get parameters or body. But in this case, since it is a post method, we have to specify the data we want to upload in JSON or XML format. In this case, we use JSON. We want to upload data to the device specified by name at the time now, and the data will be temperature data with the value 23. In this case, 23 degrees. This is how we do it on HURL, right in the destination, again, the method, the headers, and the parameters that we have explained. If everything goes well, we get an OK response, something like this. If not, we get an error message. Okay, so that's the end of this lesson. We have introduced the concept of cloud computing, web services, and REST services. REST services are widely used because they use standard protocols as HTTP and common interface that are known by any application. We have presented the basic methods get, post, put, and delete to work with data. And in the next video, we will see how to write our own REST application in Python. Enjoy and see you in the next lesson.